Hey guys, this is Mr. Riz here to help you out on the next part of the 9.1 notes. And what we're going to do is like what we did yesterday, where we found the equation of the graph looking at, or the equation of a parabola, knowing the focus and the directrix. And then we're going to see if we can make kind of a little bit of a shortcut with it. So let's first look at this problem here. We have a parabola that has a focus at 0, 4. I'm just going to kind of sketch this off to the side here so we kind of know what we're dealing with. So we have a focus at 0, 4, so or 4, 0. 1, 2, 3, 4. Okay, there's the focus. And the directrix is at x equals -4. 2, 3, 4. All right. So remember, the parabola is always equal distance from that. So we should have a graph that wraps around the focus and reflects off of that. So it should be something that opens to the right. Okay, where's the vertex of the parabola? Now, the vertex of the parabola we know is equal distance from the focus to the directrix. So we got to find the midpoint of that. Well, technically, we can think of that the directrix is at the point -4, 0. And the midpoint of that, if we add up the x's, what's 4 plus -4 divided by 2, and then 0 plus 0 divided by 2. The directrix would be at, well, -4 plus 4, that would be at 0, and 0 plus 0, that'd be 0. So the vertex is right here at 0, 0. That's going to be really important for what we're going to do later on today. Okay, is the equation y equals ax squared, or is it x equals ay squared? Y equals ax squared, if you remember, is like a happy face or sad face parabola, one that opens up or down. X is one that opens left or right. This one opens to the right, so this one is definitely a x equals ay squared problem. Okay, what is the focal length? The focal length is the distance from the vertex to the focus. That's pretty easy. We could just count on the graph. That would be a focal length of 4. And then what is the equation? Okay, so what we're going to do here is we're going to do the equation. Then we're going to see if we can make a shortcut for it. So the equation, we would have to do the square root of, all right, x plus 4 squared plus y minus 0 squared, going through and looking at the focus here. Actually, it's x minus 4. There we go. This is always minus the x and minus the y. There we go. And then equals the square root of, okay, if we have the directrix is x equals -4, that'd be x plus 4 squared. And then, well, I'm kind of running over room here, but it'll be all right, because what's going to happen here, we'll have plus y minus y squared. So, because with the directrix, remember, any y value here, and that goes away. So we know the square roots cancel each other out, and we get an x minus 4 squared plus y minus 0 is just y, and that becomes y squared, equals x plus 4 squared. So off to the side, maybe we'll do what x minus 4 squared is, or x minus 4 times itself. X times x is x squared. X times -4 is -4x. -4 times x is -4x. And -4 times -4 is 16, positive 16. So you would get, if we add the middle terms, x squared minus 4 make a minus 8x. And then plus 16. We have our y squared. And then over here, we'd have the exact same thing at the beginning here, except for it's going to be an x squared plus 8x plus 16. So we know, doing the math before, that the x squareds are going to cancel each other out, because they're the same thing on both sides. Same thing with the 16s. They're going to cancel each other out. We're going to take this -8 and move it over to the other side. And we get y squared equals, if we add that over, 16x squared, or not 16x squared, just 16x. And then to get the x by itself, because we know our equation is x equals, we're going to divide by 16, and 1 y squared divided by 16 is 1/16 y squared. And so there's the equation, x equals 1/16 y squared. Okay, what we're going to look at today is how can we make this problem easier? Now, this problem can be made a whole lot easier if the vertex is at 0, 0, and this only works if the vertex is at 0, 0, because technically these equations here is when the vertex is at 0, 0. That equation would look slightly different if the vertex was like over at 2, 3 or some other point. All right, but if the vertex is 0, 0, it's going to be a y equals some number x squared, and then x equals some number y squared. The question is, how do we figure out this number here? Well, let's look here, and we're going to try to see a trick. And maybe if we look at other examples, it can help us out. So the key here is to look at what the focus and the directrix is. The focus is at the point 4, 0. The directrix is at the point -4, 0. I'm going to go through now, and I'm going to go through Desmos and show you a couple more examples. I'm going to clear off my drawings here, and I'm going to pull up some Desmos problems that I already have done. Okay, we got a lot of graphs here, and you can see the parabolas are the curved ones. Well, I might change this one to red, just so we can see that a little bit easier. All right, so we got this blue one, this red one, and the purple one. They're all at 0, 0. Let's just look at the blue one, and then let's look at the purple one and the red one. So the blue one here is kind of like our graph here, except for this one's up or down. The focus at the point 0, 4. The directrix is at the point -4. And we still get an equation of y equals 1/16. So that number in front of the term squared is the same thing. And then the only thing different is that our focus, they're switched x and y. So, okay, interesting. So if we have it left or right, and we have the directrix and focus of 4 and -4, we still could go through. Okay, now let's look at the red one that's sideways. Okay, this one here is x equals 1/8. The directrix is 2 and 2. Well, before we might want to think, okay, 4 times 4 is 16. So that's how we got 1/16. But 2 times 2 is not 8. So maybe we can think of looking at a third one. How could we get that same problem? All right, let's look at this third example here that's upside down. We got y equals -1/32 x squared. The focus of that would be 0, -8, and the directrix would be y equals +8. Okay, so pause the video, see if you can find the correlation. So the correlation actually has nothing to do with the directrix. The directrix does help us set up the parabola, but the correlation is in between with the focus and the point. So the directrix, basically, we have to know that because it proves that the vertex is at 0, 0. But if the vertex is at 0, 0, the equation is going to be a y equals or an x equals, and it's always going to be either y equals 1/4 times c x squared, or x equals 1/4 times c y squared, where c is the number in your focus. So like if we have this problem here, our focus number was 4. 1/4 times 4 is 1/16. This problem here, our focus number was 2. So 1/4 times 2, that's 1/8. And in the problem below that, our focus problem was -8. So 1/4 times -8 is -1/32. So we can use that to help us out. We don't need to know, I mean, as long as the vertex is at 0, 0, we can use that shortcut to get the equation now. And I would expect you guys to do that instead of doing that long formula. Okay, so that's what we just went over here. And it doesn't matter whether it's x or y or up or down or left or right. We just have to be careful. You know, if it's up or down, we're going to have a y equals. If it's left or right, we're going to have an x equals. So let's find the equations of these problems. We can do it the long way, or we can go through and do it the short way. And we have to make sure we understand the difference. So this first problem says, write the equation of the parabola that has a focus of -6, 6 and a directrix of y equals -6. So if we take a second to draw that out, 0, 6 would be 1, 2, 3, 4, 5, 6. -6, 1, 2, 3, 4, 5, 6. All right, so that means the vertex would be split right in the middle between those two. It's right at 0, 0, and it would curve around the focus. It would be like this. So this problem we can use the shortcut because the vertex is at 0, 0. We just have to know, is this problem open up or down or left or right? It's up or down. Any up or down problem is going to be y equals ax squared. So what we have to do here is y equals 1 over 4 times c x squared. We got to figure out what's the c number, and the c number is the number in the focus. And we would get y equals 1 over 4 times 6x squared. We just got to figure out, okay, what's 4 times 6? 32. Is that right? Actually, no, 4 times 6. Good morning. You can see it's 7:10 in the morning here on a Friday. 4 times 6, that's 24. Okay, let's double check that just on Desmos real quick to see if that works out. Go into Desmos here. I'll clear off my work here. All right, we said we had a focus at the point 0, 6. But you know what? Let me get rid of these other graphs. A directrix at the point y equals -6. So that one's down there. I'll make that red as well so we can all see. And then our guess was, not doing all the work here, we get y equals 1 over 24x squared. All right, the graph opens up, it goes around the parabola, and the vertex is right at 0, 0. So there we go, that's the shortcut, it works. Okay, so let's use the shortcut for the next problem here. Okay, what's the equation of a parabola that has a focus at -1/5, 0? All right, so let's try to see -1/5, 0, like that's really small. All right, -1/5, 0 would be like right here. And then a vertex at 0, 0. So it would have to wrap around. So we would have a graph that goes like so. All right, so this is an x equals a y squared problem because it opens left and right. And our answer is going to be x equals 1 over 4 times c y squared. So our c is the problem in the focus here. Our number in the focus is 1/5. So how do we figure out what's 4 times 1/5, or 1 divided by 4 times 1/5? All right, so we got to do a little bit of math. 4 times 1/5 is 4/5. And 1 divided by 4/5, or off to the side, 1 divided by 4/5 would be the same thing as taking 1 and timesing it by the reciprocal, 5 over 4. Remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So the answer would be x equals 5 over 4 y squared. And let's just kind of double check that out here. So 5 over 4 y squared. It seems weird, but you know, if the problem works out, that's just how it's going to be. So Desmos, let's just clear everything off here. All right, so we got the focus is at 1/5, 0. It's very close to 0. The directrix, or the vertex, is at 0, 0. So, and then the equation, we thought it was x equals 5 over 4 y squared. Okay, actually that doesn't look too bad. When we zoom in, you can see, yep, because the focus is so close to the vertex, the graph is not going to be as wide as if it was further away. And yeah, that seems to be the right answer. Okay, guys, so this basically wraps up this part here. So in these problems here, these are going to be great problems because, one, you can't just photo math this problem to get the equation, but you have to go through and look at this problem, go, okay, does this graph open left or right, or up and down? If it's left or right, it's an x equals y squared. If it opens up or down, it's y equals ax squared. And then knowing where the focus is at, you can use the shortcut. Then you can look at this problem here and try to go through and work backwards to figure out where the focus would be located at. All right, guys, you guys have a CYU, which matches the problems that are on here. And I will see you guys next time for part 3, which is going to be difficult. You guys have a great day, and I will see you next time.